Let us find the value of a in 4.1 as per the question. We are given f of x equals to a to the x minus 1. And we are also given that b is 2 coordinate minus 5 over 9. Right? So we know that this is the x value and that is the y value of the function. So we can plug it into f. So we know that minus 5 over 9 is the y value, will be equals to a to the power 2 minus 1. So you place the y value with the y, the x with the x. Right? Now let's solve this equation. We are going to have minus 5 over 9 plus 1 equals to a squared. Therefore, we can see that a squared is going to be positive 4 over 9. Therefore, we're going to take a square root. We're going to say a equals to square root of 4 over 9. But we don't write plus minus because, let's go, I want to show something. We are told that a is bigger than 0 from the main question. We are told that a is bigger than 0, so a must be positive. So we don't put plus minus as per the norm, which is 2 over 3. And that is the value of a. Right. Now let's go to 4.2. On 4.2, they want us to determine the range of f. So f of x, so far it's basically 2 over 3 to the power x minus 1. So the question we need to ask yourself is this sign here. In this case, it's positive. If the exponential term is positive, it just tells you that the graph is above the asymptote. Yeah? In this case, the asymptote is minus 1. Yeah? This is your asymptote, will be y is minus 1. And the graph is above the asymptote because of positive. If that sign there was negative, it would mean that the graph is below the asymptote. So, ladies and gentlemen, our range would be y elements of real numbers, where y is above the asymptote. Remember, y is the function. Right, and that is your range. You don't include the asymptote. No? You don't include the asymptote. Let's do another example. Let's say I had f of x equals to negative 2 to the power x plus 3. The range in this case will be y elements of real numbers. But the y will now be less than the asymptote, which is 3, because of the negative sign. I'm sure it makes sense. Right, now let's go to 4.3. On 4.3, they want us to sketch the graph of f. We'll have to show intercepts and asymptotes. So 4.3, sketching. We need to show the horizontal asymptote. So I'll just say asympt. Its y is equals to minus 1. Now let's do the y-intercept. Y-int, remember x must be 0. So f of x is basically 2 over 3 to the power x minus 1. So we're looking for f at 0 when x is 0, right? Which is 2 over 3 to the power 0 minus 1, which is 0. So, which means we have 0, coordinate 0. And then we know a point, right? We already have a point. B is 2, coordinate minus 5 over 9. Okay? So now I have 2 points and the asymptote. I can easily sketch my function. The reason why I don't do the x-intercept is because I can see I'm passing through the origin. So I don't have to do the x-intercept. So my graph will be rough sketch like this. The y asymptote is on -1. So we put y equals to -1 there. The first point is on 0. The second point is 0 and 0. The second point was 2 and -9/5. Let's check that. Okay, we don't have to even check. Now remember, we're just rough sketching. So 2, -5/9. That should be somewhere there. Just rough sketch. Ne? Not there, not there, not there. I'm wrong. It's negative, so it should be at the bottom, right? So we can say somewhere there, for example. Somewhere here. -5/9 would be somewhere there, sharp. And then we don't touch the asymptote. And then that is our function. Okay? Now let's read 4.4. What does 4.4 need us to do? They say it is further given that C is a point on F at y equals to 19/8. Okay, let's do that. So let's write f of x down. Actually, I'm going for, let me just go right at the top there. We can write here the space. We know that f of x is equals to, well, ladies and gents, I think let's just erase some parts so that we can be clear with what we're writing. Okay, so far we know that f of x, right, is equals to 2/3 to the power x minus 1. And we are told that the y value at C is 19/8. That is the y value at C, right? So let's go and get that. Let's get the corresponding x value. So I'm going to substitute 19/8 is equals to 2/3 to the power x minus 1, right? And then let's just erase this part. Okay, and then we have 19/8. We're gonna add 1 there. We're gonna add 1. So that gives us 27/8. And then this side we get 2/3 to the power x. Then we know that 27 is 3 to the power 3. And then we know that 8 is 2 to the power 3, which is equals to 2/3 to the power of x. All right? And then from here, I am going to do this. I can see that here I can have this. Now I can have 3/2 all to the power of 3 is equals to 2/3 all to the power of x. Yeah? Okay, now I'm going to do this. I can switch them around like 2/3, but I have to change the sign of the exponent to make it a negative. And then I have 2/3 x. Then I can see that x is equals to -3. All right. We can all see that x equals to -3, ladies and gentlemen. And then we know that point C is going to be -3 coordinate, 19/8. And then C, we are told that it's reflected. Let's go and check. We're told that it's reflected along. They say determine the coordinate of C reflecting the image of C when C is reflected about the line y equals to x, which means the value of x becomes y, the value of y becomes x. The value of x becomes y, the value of y becomes x. So here we're going to have 19 over 8, coordinate -3. And that's it, ladies and gentlemen. And that's how you tackle exponential functions, intercepts, graphs, and reflections like a maths ninja. Keep following the 2-in-1 maths plug for more lessons. Like, subscribe, and keep grinding. Remember this, maths never sleeps.